Well, I think let's go ahead and kick it off. Jason, if you wouldn't mind joining me up on the stage here.
Yeah.
Cool. I'm going to pop my webcam up. So everyone, welcome. Just thanks for being here. We're so excited about this. This is the inaugural Babylon Monthly Meetup, and it's really just a pleasure to be here with all of you in such great company. My name is Gabe. I'm the founder of Frame. I'm in California. Many of my teammates are in here as I look around the theater. We're from all around the world, and I see a lot of the Babylon team here as well, and a lot of people from the Babylon forums and other places too. Just a very cool gathering. We're really lucky to have an incredible lineup of presenters today. I tossed the agenda up over there to my right shoulder. So just by way of a little introduction, why are we doing this? First off, we at Frame, we've been building with Babylon for a while, and we love everything about it. The library, the team, the community, the forums, and we love the idea of a place where the community could come together and kind of bond and learn from each other and just sort of get inspired by Babylon-related presentations. And we're kind of coming out of this this pandemic, and I know I personally am feeling as hungry as I've ever been for connections and connecting with communities with shared passions. In this case, the beautiful, performant 3D graphics on the web library, Babylon.js. Now, first, a few ground rules. The first one is just sort of bear with us. This is the first one, and we're going to learn how this thing goes and improve upon it. Don't unmute during someone's presentation. You can unmute during the Q&A after each presenter if you'd like to ask a question. You can ask questions in the text chat anytime you'd like. That's up at the top left. I'll say hi there right now. Feel free to say hi there as well. I actually have this translated into French right now, so let me turn that off. I was demoing that. So there we are. And the presenter can decide if they want to address those questions right when they get them or during the QA phase. Emojis always are fair game. So there's a little emoji button down in the toolbar at the bottom. Please be positive. Just generally, we want this to be a warm, supportive place. But you can be rampant with emojis as you want to express your excitement about the mind-blowing stuff that you see. And if things go haywire on the tech side, which is a definite possibility with any online communication or collaboration platform, not just Frame, but generally a refresh will solve it. So if things seem strange, like you're not getting audio or you're not seeing a screen share, just refresh. You'll get plopped right back to your seat. I do want to say we have an update coming on Wednesday for Frame that actually makes these larger scale meetings a lot smoother and more performant, but I think this one will go just fine. And then just generally be polite and treat others as you'd like to be treated. We want to make this a warm, supportive environment for people of any level, beginner Babylon people who might be learning about it for the first time or the more advanced experts. All right, well, if all that sounds good, on the topic of Babylon, I'd like to introduce Jason, Chief Pirate of Babylon.js, who convinced me a few years ago to build Frame with Babylon. And he's also been a great friend ever since. Jason?
I appreciate that. I'm going to try and share my webcam here, see if I can get that figured out. Hey, success. Yeah, I just wanted to say welcome as well to everybody, and thank you so much for being here. On the forum, I'm Pirate JC or Jason, and I have the privilege of being the studio manager at Microsoft of the Babylon team, kind of helping run the show. I like to say that my job is to support one of the best teams in the world. That's really ultimately my job. But the purpose of us coming together is really just to kind of spend some more time together. You know, it's the forum is asynchronous in nature, and while that's great, it's a great place to learn and ask questions. This is a place for us to get a little bit more intimate, to get to know each other a little bit more, and to share some stuff that's going on. about Babylon and what you're working on. But one thing I definitely want to say is, as Gabe kind of mentioned, there's been this really kind of beautiful like friendship and relationship that's kind of been built with Frame and Babylon. And it's been a real pleasure for us who are building the platform to see what Frame has been able to do with the technology. I mean, really, if it's not too much to say here, when it was first kind of getting started and first looking at coming over to Babylon, it had a lot of potential. But what the Frame team has been able to do kind of with the platform has been honestly kind of remarkable. I mean, Paul is giving me a run for my money on what's possible with NME, and the performance stuff that y'all are getting out of it is just incredible. And it's really becoming an incredibly powerful and well-known metaverse platform. And to see what people are able to do with Babylon has been really, really impressive. So I just want to echo, welcome to everybody. We hope this is the first of many of these. I also want to echo that this, just like the forum, should be a place of kindness and compassion and love for one another. That's what the Babylon community is all about, and we want to continue to do that here. And so I'm just super pumped to hear from our speakers and super pumped that you're all here. And so thank you very much for being here, and we'll see you at all of the upcoming ones as well.
Awesome. Love it. Without further ado, I'd like to bring our first speaker up to the stage, Paul, who I think has to grab something behind the scenes in support of his talk. And this, while he's doing that, maybe a good note to all future presenters. During your presentation, yeah, you can do the basics like screen share, but if you want to bring in a 3D model, you can. If you want to bring in a particle system or a shader, you can. So this is another one of the reasons why we should be meeting in something made with Babylon as we do this stuff. All right, Paul, over to you. And Paul, you are...
Oh, right. Yeah. I'm just going to share my screen real quick here. And we're going to be... All right. Let me know if you guys can see that.
I've got it.
Fantastic. Well, good morning, Babylon Meetup, or depending on wherever you're from, it might not be morning, but hopefully it's a good one. Thank you, Pirate JC, for that intro. Wow, I'm really excited to be here and talk about one of my favorite topics, which is NME. And here, when we were, I was tasked to make this new scene for Frame. I really wanted to make sure that it was moving in as many ways as I could make it. So I went through this this whole process of trying to explore what we could do with the vertex output, and how we could incorporate those movements in a really seamless way. And so the first thing I'll highlight is these trees that are on a global wind shader. Where it's a global noise moving through, and the same shader is affecting the grass as the branches of these trees, and it was something that I really struggled to put together, because the first time I just put the noise shader on, the trees looked like they were too, they looked a little bit like mush. And then I thought, all right, well, maybe I put bones in them, or maybe I do some other kind of experimentation. So the first thing I was like, all right, let's start from scratch and let's try squashing things and moving things in whatever ways that we can. So here, we've got squash and stretch, and then I was thinking, man, I really wish I could rotate this. So then I went to the forums and I found a post on doing some rotations, and I'd actually meant for this to not be here. So if you take, if we take 1 second, I'm going to take this away. And I really love the idea of matrix transforms. So just using a little bit of matrix math on a four-dimensional matrix, we got just some simple rotation happening. And I was like, this is so cool, because we can use this in so many ways, and it's wonderfully additive. So then if we just take this real quick and grab a multiply, then we're getting some complex rotations happening, and that's super quick. And then like you can go in here and have these things change on the fly and just have some really cool motion happening. And then I was thinking I could use this as a rig for these leaves for, we'll get to these, and then drive the rotations in this tree by a matrix builder. So now the global noise is affecting the rotation going into the matrix. And so now each one of these things are rotating in that way. And then I was like, the sky's the limit with this. We can just keep pushing this concept. And when it came to making one of the items in this scene, which I like the term kinetic architecture. I wanted these bars softly, procedurally moving in a twist. And the first time I tried to do it, it was like, all right, well, this is black and white maps, and we're pushing it along the x-axis, or we're pushing it along the y-axis, and we can do that with sine waves. And none of those answers were good enough for me. I was like, these are cool, but how can we push this further? So then I came in, and the concept was, well, we have twist. We have twisting rotations. And the way that this is twisting is along a three-dimensional mask. So now, using the distance modifier, I can create a three-dimensional mask anywhere on the mesh, and I can move that mask around procedurally. But then I came to another problem when I was doing these tests on it, and that is that the further you get away from the center of the object, because this is rotating, as I was showing, around the center of the object, well, how do we get that to push away from the center? And the way that I solved that problem was in taking these matrices and pushing the matrix itself away. If we come in here and we can start to just move these matrices, and but it's still rotating along the center. Well, then I just grab another matrix and I move it back. So then now the problem is solved, where the pivot of the entire object is being tricked at every frame. So now it doesn't matter where we want to place this mask or place that rotation. It's going to happen right there. Excellent. Oh man, you guys are great. And so then, yeah, we can procedurally like change these things. Right now, this is just happening on a mask of a sine and a cosine, and it's so fun to play around with these values. Because one of the things I was thinking of too at first when it came to doing the twists was, all right, well, let's just put in the morph targets. And morph targets are cool, but morph targets are not this flexible. If I want to make a distance shader where the distance of the camera is affected by this, then I would have to put in so many more morph targets to make sure that procedurally works in the way that we want it to. If we want to change just any number of how far this mask goes, if we want to make this, take it to absurd values and push it, we're almost seeing this look like cloth in a way, and I can see this being used in such a way. And yeah, I really think that the sky is the limit. This is just barely touching on this topic, but I'm so excited about where this can go. And the fragment shader output is almost nothing. It's grabbing just the mask of this, and so mixing this with all the cool stuff that we can do with the fragment, I'm just really excited to see where this can go. And that is my talk. Thank you guys so much. Thank you, Delta Kosh. Thank you, Pirate JC, for coming here. And yeah, I'm really excited for the next talk, custom deformations in skinned meshes. Thank you so much.
Amazing, Paul. And Paul, would you mind hanging out just in case anyone has any
absolutely. Absolutely.
If anyone's got any questions, you can ask them in the text chat, or you can flip your microphone on. You might want to turn your megaphone on too if you're in the back row, and feel free to just say anything. Someone asked if this was recorded, because there's a lot of stuff went over there, and this is being recorded.
Great. Does anyone have any questions?
Hey, Paul, could you just share that finished scene one more time? So we can
Oh, absolutely.
and appreciate
And then
it.
you've got one in the text chat, Paul.
Oh, wonderful. Oh, yes. So absolutely, I have an example here. The question is, did you have any problems rendering the shadows from the shaders that change vertex offsets? And if you come in, these bars stay flat in the shadow, but they're moving up there. It's something that yeah, we're just gonna leave it for now. It all looks cool, so yes, that is absolutely a problem with this, but it was worth pushing the system anyways. Another question from Eric. It would be nice to have a library of custom node groups. Oh,
That's
absolutely.
not a question. That's just a feature request.
We can now control shadow material with NME. Oh, that's excellent. I didn't know that. See, I come up here, I learn things. 1 second while we're waiting for more questions. Another thing I really loved about this, and I said distance shader, and I didn't bring it up in the actual talk, but I was really excited about this concept of using the distance from the camera to drive just the textual information. This is an NME as well. And if you get, oh wait, not webcam. If we get in here, then yeah, we can see it. Really nice. And then this is a concept that I wanted to elaborate on with deformations in the future.
All right.
Cool.
If we're ready to roll on. Okay, Jacob, really fast to your question there. You can't really look at GLSL in the NME itself, but you can export the code from the NME, but you'll kind of get it in this Babylon block format. There's a lot to unpack there with that question, and I'll be happy to chat with you more about that, as I'm sure many others will too. All right, cool. That was awesome. I'm going to move this awesome shader over here. We can keep staring at it because it's so epic. One little note, you can zoom into the streaming screen. I forgot to mention this before. I apologize. If you click on the streaming screen, you should be able to zoom into it once there's something on it. But okay, great. I would now like to introduce our second presenter, Hyeon Jong Nam. Not sure if I'm pronouncing that right, but I really like that this fellow just like threw himself into the mix on the forum. We said, hey, we're doing this thing. We're making a call for presenters. And in just like a little bit, he was like, let's do this. I've got an epic topic. So let's hear about custom deformations in skinned meshes. Go for it.
Oh, can you hear me?
We can hear you. Make sure you have your megaphone on as well next to your microphone.
Oh, okay. Hello, I'm Jong from South Korea, and this presentation will cover how to implement custom deformation in skin mesh. I started using Babylon.js to develop the MMD loader in April 2023, and this presentation is also part of the MMD loader implementation. We will first discuss the need for custom deformations and how to implement them, and how to make our existing elements support them using a slightly risky method. Let's start with why we need custom deformations. Typically, many 3D rendering software, including Babylon.js, use linear blending skinning to handle the blending of joints. This is implemented by simply linearly interpolating the resulting values of two matrices, which is a cheap operation, but it has a problem. As shown below, joint with LBS will collapse if they are rotated by a certain angle. Various other deformation methods have been proposed to solve this problem. And I implemented spherical deformation, which exists as a specification in the 3D software MMD. Let's take a look at the resulting implementation. You can see that the spherical deformation is rotated without collapsing and maintaining the volume of the joint as shown below. SDEF prevents joints that have a fairly free range of motion, such as shoulders, hips, and knees, from collapsing in shape. So how do I apply a deformation method like SDEF to existing code base? Here is checklist for implementing custom deformations. In total, Babylon.js provides 3 different deformation methods to ensure that skin mesh runs properly on multiple devices. CPU-bound deformation, GPU-bound deformation using uniform buffers, and GPU-bound deformation using textures. If you have used skin meshes before, you have probably used these settings to choose your preferred deformation method. You will need to override all 3 methods to fully implement your custom deformations. So let's start with CPU-bound skinning. We need to add the necessary parameters for our deformation, which we can do through the setVerticesData method of geometry class. Now, we just need to override the existing implementation. CPU-bound skinning is done by the mesh apply skeleton method. So we will override this method and then branch to perform a different deformation for the vertices we want. To override GPU-bound skinning, we need to inject the desired code into the existing shader. To do this, Babylon.js provides an interface called Material plugin. Using the Material plugin, you can create shader defines, bind any attribute to the shader, and finally, modify the existing shader code. In this way, you can see that a define macro called SDEF has been created in shader code by a method called prepare defines. Binding an attribute to be used in shader can also be done in this way. In the end, the most important thing is to find the right injection point to inject your code. And our skin meshes use the code final word equal final word multiply influence at the point of applying the result of the skinning operation. So using this code at a point, insert the deformation code at the top and then use mix to select between the original influence and the new result. The implementation looked like this. We have used a regular expression to put the injection point in key and the vertex shader code that does the deformation in value. Here is problem. The problem with implementing deformation by injection like this is that the deformation is only applied to the shader of material. The reason why this is a problem is because in the actual rendering, the depth map renderer and shader map renderer also have their own vertex shaders that need to have custom deformation applied to them as well. If you look at the image below, you can see that the custom deformation is not applied to the shadow map. So the shadow and mesh do not have the same shape. To solve this problem, I came up with two solutions. The first is a feature provided by Babylon.js that allows you to add a global custom shadow map shader to the shadow generator. However, this only works for shadow maps and does not solve the problem of the depth map renderer used in post-processing. The second approach is to find a method that generates the shader in the engine and contaminate it, forcing shader to be modified at creation time. This seems like a pretty risky approach, but if implemented properly, it would allow us to support custom deformations for our shaders, even those implemented by someone in the future. So I decided it wasn't a bad option. So I found the entry point where our shaders are compiled, and that is engine create effect. In order to inject code in this method, we need to take a closer look at what parameters the method takes. What we need to pay attention to here is the I effect creation options. I effect creation options used to have a process code after includes API, which is a more raw form of the material plugin. Using this, you can easily inject code for our shaders. The most important factor in contaminating the create effect method is that our functionality should still work properly after the contamination. The two images below show two different ways to call create effect. The method on the left, which uses the I effect creation option parameter, is the only way to inject code. So you need to convert any other code to use I effect creation option. Now let's contaminate create effect. The basic form of code is to save an existing method and replace it a new method. We will also make sure that all calls to create effect use I effect creation options. Finally, we look at uniform and define appropriately to determine if this is code that needs custom deformation and inject attribute, define, and code. Then all of our shaders now support custom deformations. To summarize, custom deformation on a skinned mesh can be implemented by using the material plugin and creating a class that inherits from the mesh class. By contaminating create effect, custom deformation can be applied to any shader. Thank you. Please contact me by email address if you have any questions or need any information about my presentation. Thank you for your attention and thank you for setting up this occasion. I apologize for my poor English.
Your English was amazing and your presentation was awesome. It was so good. Cool. Yeah. Could you leave your email address in the text chat so that people can follow up with you?
Okay.
Cool.
Here's my email address.
Amazing. Alrighty, and then just you can close out of the streaming screen. You should see a little red X at the top left. Perfect. Okay, and let's dive into our final presenter with a secret Babylon surprise. This is David of the of Babylon. Welcome, David. You want to say a few words about yourself before you dive in?
Sure, of course. Let me turn on my camera just to see if it's working.
And make sure you've got your megaphone on as well, just in case you don't.
Yes, it's on. All right. Hi, everyone. It's such a pleasure to be here. Can you hear me? Yes. All right.
Yep, we can hear you.
Okay, good. So yes, let me look at the camera. So I am super happy to see all of that. That's just a personal accomplishment. Like, I won't lie. I wanted to have something very special for this first meeting, and so I kept the surprise. So you know what? I'm gonna just jump into it immediately. So let me share my screen. I'm gonna pick the window I want, and you tell me if it's working. It is?
Yep.
All right, so please let me introduce you with a new node editor, the new node geometry editor. So that's the browser or the sister of the node material editor, and it's gonna bring the procedural aspect of what you add in shaders on geometry. So if you know Blender, it's typically a clone of the geometry nodes in Blender. So the initial question was, okay, I wanted to create a tiny demo where I add a city, like a city with several buildings. And my point was, oh gosh, if I need to do that, I'm gonna have to download like hundreds of megabytes of data, right? Because I wanted to have, I don't know, like 50 buildings, all different, right? And so the point was, oh gosh, yes. And I was playing Diablo 4 at that time, which is a bad game, by the way, but that's not the topic here. And they have this technology where they can start from chunks of data and assemble them in a way that create an entire dungeon, right? So instead of having the entire dungeon modeled by someone, they just model some of part of it, and then they assemble that. So the procedural aspect of a geometry is cool because it's going to save download time, which is a pain on the web, right? And it's going to give us a way to generate infinite possibilities. All right. So you know what? Instead of speaking like that, I'm going to show you how it works right now. You are familiar with node material. We saw that just before with Paul, and I just changed the color of this editor. So the node material has an accent of blue. The node geometry editor has an accent of green. What you do is you define with sources here like box, capsule, cylinder, mesh, plane, etc., a geometry that you want to play with, and you have a geometry output at the opposite. So this will generate a mesh that you can then use like any regular mesh, right? So far it's pretty dumb. It's just a box. Like, and if you want to, for instance, have, I don't know, like a icosphere, right? You just plug the icosphere instead, and boom, you have an icosphere instead. Right. Cool. Nothing super fancy here. Let me get rid of these boys here. I'm gonna just use a grid for my example. So let's say I have a grid. So the grid is basically a plane, right? But you can control the subdivision. So if you move here a subdivision entry and say I want between, you know, like 0 and 100, you can subdivide your object right there and generate the geometry you want. From here, what I want to do is to create a ground, like some kind of a ground for my demo, right? And I will, how can I do that? Again, if I want to do that with Blender, 3ds Max, or any DCC tool, I will go there, create my object, save it as GLTF or Babylon file, export it, and load it, right? So you're going to have to translate through the network. And it could be quite big. Like if you look at the geometry node here, you have the information of the final output. So let's say I have, I don't know, like 40 or 38 subdivisions. We end up having something like we've already more than 1,000 vertices, right? So what can I do here? I will use a set position object. So what I do here, that works as well in enemy. By the way, you just hit space, right? And it will just open the node picker under your mouse. And you can then drop on a wire and it will automatically wire. So set position here, what does that do? It's just going through all the positions of your mesh, right? And you can provide a new position collection here. So my collection here right now would just be the same, so no changes. But what if I add also a normal, for instance, right, here, and I will add the two of them. So let's say I'm doing that. I add my position to my normal, and I set that. Okay, oh, where is it? Actually, it's higher, right? You think about the plane. The plane, we add on every single position the normal, so it just moved higher. Okay, but what if now I will change the value of the normal based on something like a noise, like a purling noise. So I'm going to take a noise point here, okay, and I will generate a vector out of that. So what I want to do is actually multiply my normal right there, here, no, not you, here. I'm going to take my normal here, multiply it by my converter right there, okay, and plug that and add that to the position. So I don't want to always add the same normal, right? On the plane, they are all the same, but I want to apply a noise on the normal before adding that to the position. So I'm going to take my noise here, put that into Y, and boom, I just generated a ground, right? So the ground is weird here. Why? Because I moved the positions, but I did not recompute the normal. So I'm going to compute the normals. Oop. And now I have my ground. Okay, let's say I'm going to just play with my octave a little bit to get a little bit more complexity, right? So we see it. We have the ground of my new game where I'm going to add some stuff. Cool. You have options here to use a matcap if you want to see better rendering, I would say, or just use the wireframe. So that's the first step. It's cool. What I can do now is actually go further and say I'm going to plant some trees on top of it, right? So what I need now is a new name. It's instantiate on faces, right? What will that do? It will take the geometry, and on every faces, it will allow me to implement a new geometry. Like imagine that we have all these faces right there, like the tiny faces. I can ask the system to instantiate, add more geometry on that faces. So we're going to just build quickly a tree. I am not as good as Patrick on creating 3D for sure, but I'm going to try to do something like a box here with, you know what, the trunk could be just a dumb cylinder. All right, let's move all these forks right there, and I'm going to merge them, right, with a merge node here. So I take one geometry, I merge the second geometry, I look at what it is. Okay, so I have my cylinder and my box together. What I can do first is here on my cylinder, I'm going to transform the cylinder, right? So I can translate it a little bit down. And you can see like that's new compared to NME. You can plug value on every node, or you can directly edit the value of them right there. So you don't have to plug them. It helps keeping the system cleaner, I would say. So -1, look at that. That's a wonderful tree, right? Maybe not yet. It's not obvious, but what I can do is change the diameter here to something like 0.3. All right, wow, that's a stylish tree, right? I'm so happy. What I can do now, okay, going back here, I'm gonna reconnect my compute normal here. And I'll use that merge as the instance on my instantiate on faces, all right? And now it's not working anymore. Cool, what did I do? I broke something apparently. Okay, it's beta, right? Maybe I should have mentioned that, yes, okay. I had a update issue. Anyway, so here it's a bit too much, right? If I want to see the ground, I need to add a merge here at the end. So I merge my ground as well with my instantiate trees, and I have that here. So we don't see the ground because the trees are far, far too big. So before instantiating them here, I'm going to transform all my trees, right, with a scaling operation like something like probably 0.015, something like that. Yes, it looks far better. So here I have, oh wait, 0.05. So here on my terrain, I have my trees. Oh gosh, they need to be moved a little bit higher, probably 0.1, no, less than that, 0.5, less than that, 0.1, yeah, 2, tree, maybe? Yes, okay, it's fine. Okay, I have trees on my terrain, right? Okay, they may require a bit of like variety. So what I can do is apply some scaling on every instances, right? So I can add a random node here. A random node, okay. My graph is a mess, right? It's always the problem. So that random node here will be used with a vector converter to generate a vector out of it. So I want to apply the scaling on all axes, right? And the scaling will be between 0 and 1, and that will be my scaling here. So, which, that's too much. Where am I? I am here. Oh gosh, no, I was overwriting what I did before. I'm done. Yes, I need a second transform node here at the instantiate. Perfect. All right, and now you can see I have my trees which are all at different sizes, right? Something is weird with the size. They are kind of flat because I didn't use, yes, X, I use W here. Okay, right, perfect. So you see they have all the different size, so it's more variety. What you can do as well, and I'm gonna finish the demonstration because I could go forever, you can add a property which is set material ID, because so far if you look at the outcome here, the generated object only has one submeshes, meaning that all the geometry has the same material. But you can use the support of multi-material that Babylon.js has to actually apply a specific material per entities. For instance, here what I want to say is, okay, you know what? The trunk and the leaves, yes, will have a different material ID. Like I can come here and say, okay, the trunk will have a material ID of 1. So see, boom, they have a different color. And the trunk has a second material ID of 2. So it's not obvious, but it's like a different green. And so out of that, I can save everything on a file or, of course, to our snippet server. And I can load that from any code, exactly like enemy. So let's go here. This is what I did with another geometry editor. Exactly with what I just did, I created a city made of, so the entire code is here, like you have everything here. It's super small. I don't know how many I get at the end. Gosh, ground, dispatch trees. Where am I? Sorry, building. I should call building. Anyway, here, 10, 40. Okay, I have 40 buildings in my city right there. Okay. Or 50, and none of them are the same, right? They are all built from a set of several objects, right? Meshes. So I have ceiling, gap, straight, windows, window 2, corner 1, corner 2, hot corner, etc. And I apply rules, right? For instance, I say if I am at level 0, I have specific parts that I use, right? Which are this one with the concrete. Then up to the ceiling, you can use different for the corners, and you can have windows with or without windows or specific stuff. And at the end, on the latest one, I have this specific corner one. And that's all controlled from a one single node geometry, which is right here. So it's integrated into the inspector, of course. So if I take one of the buildings I generated here, you have a button when they are made from a node geometry, you can click edit, and that's a monster. This one is a big, to be fair with you. What happens here is like, at the end, at the very end, we have an instantiate of vertices. I'm just taking a box, right? That's my box, okay? And that box here, let me just try to keep that here. You can see the demo here. It's all controlled by one single input, which is here, which is main height. So the height could be 1, you see, and when I manipulate that, the system...
David, we don't see the window. We don't see the window.
You don't see the window?
I think...
oh, gosh, yes, because, okay, yeah. Sorry. Let me stop sharing and share again, because it's a new window. You're right. I should share the window, actually. Let's see. Share. Is it better?
Yes.
Okay.
Yep.
So... start again. Right, that's the monster I'm talking about, right? And it's all controlled from this value here. When I change the value, right, you see that the building dynamically adapts, like in a snap of a finger. Actually, it's less than a snap of a finger. It's probably something like, you know, you have on nodes when it makes sense here, you have the value, the time spent to generate this. So it's 100 milliseconds to run the simulation. And at the end, it generates something like 1/2400 vertices. And so everything is built to be controlled by this unique value, right? For instance, the system will check, okay, you're going to instantiate on vertices of that box, right? I am using the new feature, which is the teleport out and teleport in, that let you actually send the value to other value in the graph, so you don't have to have a lot of lines just to keep it cleaner. And here, the instantiate of vertice will take one geometry, and that geometry is using actually a test, like for instance, greater or equal. So here, for instance, I am looking at if from the position in my box, okay, if the x is greater or equal than 2, I will pick one geometry or another geometry, which in turn are actually new tests, okay? And that way I can test, okay, am I on this face or this face or this face or this face, like one of the 4 faces of my building that will give me information, or am I on the corner, or am I at the lower level? All of that is actually just evaluated by the system to build the final outcome. So I'm literally downloading, I guess it's 5 megabytes of assets, and I can build an entire town, which would have probably be hundreds of megabytes to download. And the user can then change something and adapt. Like I can think about frame where the environment could adapt just with a click on a button, like, oh, I don't want X number. Like we have now 47 people, so we can adapt the stairs. But let's say we are 1,000, the stair can build again with more people to support. Like the possibilities are infinite. And I'm gonna stop sharing right now and get back to my camera if we have any questions. I talk a lot. Sorry, it's a topic I love. Does anyone have a question or stuff that you want to know?
Yeah, hi. This is Dan Senny from the Frame team. I saw this actually last night as I was rereading the documentation. I was really excited to try it out. So thanks for demonstrating that for us today. Pretty amazing feature. I do have a question about, I know that this is like something that could really help or is meant to help with cutting down download size of assets.
Yes.
Compared to like doing this in Blender using the node geometries.
Correct.
But I'm curious, I see you're using like bits and pieces to build that city, and it, obviously leaves a lot of flexibility in order for artists or whomever to change those features on the fly. But I'm curious, once you serialize all that data, do you still expect to have a significant benefit over downloading the actual asset as if it were exported from Blender?
The thing is, it's happening on the client code, right? Like you don't have to download anything. So you can have two, if I understand correctly your question, of course, but you can expect to generate it once and just dump it as a GLB file, right? Why not, right? Because at the end, it's pure mesh. Or you can regenerate it every time you need it. Does that answer your question?
I think so, but the regeneration process has to happen either dynamically, or it has to be parts from some serialized data, right? Or am I misunderstanding that?
No, you're right. Yeah, the expectation is every time you launch the system. Again, I can use the stairs here in this in the scene in frame here as a good example. Like you can adapt dynamically and regenerate dynamically the stairs and the number of stairs you want based on the number of people who we have in the meeting, right? Mm-hmm. And so that could be done dynamically. But you can also build a mesh and just treat it like a generic mesh, meaning like you save it as GLB or Babylon and then load it again. But then you're going to pay the price of downloading it. I do not expect the mesh generated to be smaller than a mesh that you will generate in Blender, right? Because at the end, it's the same geometry.
Okay. So once all that data is serialized, we should probably see like kind of comparable sizes between.
It's probably very comparable. Yes.
Okay.
One thing that the NG is doing, Node Geometry Editor is doing, which is I don't know if we have that in Blender, but it will pack together all the items with the same material. You know, when I use the set material ID, that I use that a lot in my demo here with the city, because every single part has its own material, right? And so at the end, to optimize, when you look at a mesh generated with NG with that, there is just the minimum number of draw calls. Like, for instance, a building with 6 different parts will have 6 different draw calls, period. Right? Because the system will, at the end, what I call defragment, pack together all the geometry which are attached to the same material. Whereas when you are in Blender sometimes, or any other stuff, depending on the order of the output and the vertex output, you can have, even if you have twice 2 blocks of geometry using the same material, if they are not together, they will do 2 calls, right? Because first part and second part. What NG is doing is packing everything. So I want to guarantee that you don't have more draw call than required. For instance, the scene that we have here, the one that I show you, has 11 million, 1 million, sorry. Wait, I'm just checking. Yes, 1 million vertices, right? But it renders smoothly because the number of draw call is super limited.
All right, very cool. Thanks so much for answering my question and for presenting this awesome feature. I'm really excited to start dabbling with it.
You know what? I can't wait to see what you guys will do. I look at you, Paul.
Thanks so much.
Awesome. I'm so excited for this.
Everything is available right now, by the way, so you can go to ng.babylon.js.com. The documentation is at the beginning, but Patrick will take care of it and will make that good. So yeah, you can try it right now. And the demo, the one with the city, is available in the doc. That's the first link in the documentation. And voila.
Amazing. Well, thank you so much, David. That was epic. And this has been really epic. I got to say, for the inaugural meeting here, it's been so fantastic watching these presentations and seeing all of you and seeing Frame not explode into 1,000 pieces and break everyone's computers. It's just been great. I do want to say, for anyone here, we're going to have more of these, and I hope that you invite any of your colleagues or friends who might be interested in Babylon to the next one. If anyone is interested in presenting at the next one, we'll have another forum post on the Babylon forums where you can just let us know what you'd like to present on, and we'll get you on the roster. And yeah, we're going to probably try to mix up the time a little bit just to try to accommodate some other time zones. But it did seem like this was a pretty good one for this crowd at least. So we'll kind of see how that goes. Yeah, this was just fantastic. I'm going to I don't have anything formal, I'd say, planned for the end of it, besides just if you want to hang around and mingle and meet and greet. Backstage, we've got a couple private audio zones if you find the conversations getting a little too jumbled. But in any case, if you're headed out, I hope we see you next time. And if you want to hang around and say hi to anyone who's here, then here's your chance. Thank you all for coming.